flagpole, I don't care. Whatever we're around, it's going to be one less factorial. So good job. All right, number 10. This is page 10 in the packet. Problem number 10. Here we go. Bowl A contains all this. Bowl B contains all this. If you pick one M&M, what is the probability it will be blue?
Are you picking it from like either bowl?
Yeah. So now wait a minute. Wait a minute. Wait a minute. This is going to be a tree diagram problem, right? Because what's the first thing you have to decide?
Bowl A or bowl B.
Bowl A or bowl B, and then the probability is different, right? So step one, pick a bowl. Bowl A or bowl B? What's the probability you'll choose A? 50%. Actually, I think I'll use fractions. It looks like these guys are going to be fractions. Doesn't matter. Use whatever you're comfortable with. I'm going to use fractions this time. Now, when I reach in and grab an M&M, that M&M is either going to be blue or green, right? Do you agree? So let's say I'm in bowl A. What's the probability of getting a blue M&M out of bowl A? 4/10? And the green one then is 6/10? What about bowl B? 5/7 and 2/7? Now I want to get a blue M&M. I want to get a blue M&M. So I'm either going to get a blue M&M out of bowl A, and that probability would be 4/20. I'm not reducing yet, I'm just multiplying them. That would be 4/20. Or I can get a blue M&M out of bowl B, right? Which would be 5/14. All right, so that's 1/5 and 5/14. You obviously have a calculator on this test, so I came up with 39/70, but I have no idea if that's right or not. Did I add right? Did I multiply and add? All right, there you go. In general, Harry is tardy 1 out of 3 days. What is the probability he'll be tardy exactly 8 days of the next 10? Think about your various strategies. What strategy, probability strategy, seems to fit this situation? Every day, what happens? He's either tardy or he's not. Could we do a tree diagram? We absolutely could. It would be huge because you're doing this 8 out of 10 days. So you have to do 10 branches of the tree. It's like flipping a coin or guessing at a test question. Every day's a new day. Pascal's triangle. This is a binomial probability problem. So the fastest way to do it, not the only way, because you certainly could build a tree diagram. You certainly could write out all of the outcomes. That would be like a tree diagram. But the fastest way is to do it as binomial probability. We're looking at 10 days. What would 10C10 represent? 10C10 would be 10 days, tardy all 10. 10C9, the next term in the row, 10C9 would be 10 days, tardy 9. We want 10C8. So our coefficient is 10C8. And then he's going to be tardy or not tardy. There are 10 days total. We're going to choose any 8 of them for him to be tardy on. What's the probability he'll be tardy? No. Look at the problem, it tells you. What's the probability he's tardy? 1 out of 3. Then what's the probability he's not tardy? 2 out of 3. How many tardies do we want? 8, and that means there are 2 days not tardy. Okay? Remember, this is kind of the opposite of conditional probability. You can use binomial probability when you are doing the same thing over and over and over again, coming to school, coming to school, coming to school, coming to school, doing the same thing every day, or over and over again, I should say, over and over again, and the probability stays the same. Flip a coin 50 million times, it's always 1/2, 1/2, right? Always. All right, here we go. If I have 10 shirts, 8 jumpers, 2 sweaters, and 2 pair of shoes, how many outfits do I have? 10 shirts, 8 jumpers, 2 sweaters, and 2 pair of shoes. How many outfits do I have? How do you do it? 10 times 8 times 2 times 2. Now, before you get confused, I want you to think about this. In the morning, I go to my closet. I gotta pick a jumper. There's 10 ways for me to do that, right? And I gotta pick a shirt. And I gotta pick a sweater. And I gotta pick a pair of shoes. Now, don't put factorials on those. These are my 10 jumpers. I am simply choosing one. Am I arranging them? Am I laying them out in a row and arranging them and all that crap? No! I am picking one, and there's only 10 ways I can pick a jumper. Actually, there's more now because someone gave me 2 more yesterday. So, but there's no factorials here. That's the key. All right, 5 mathletes, 6 football players in the room. I'm selecting a team of 3. How many teams have at least 2 mathletes? 5C2
times 61.
times 61. What's that? What's that right there? 2 mathletes and 1 football player. Is there any more to this problem, or do I stop right there? I keep going. What does at least 2 mean?
It could be more.
There could be more than 2. Now, it's only a 3-person team. So it's either going to be 2 mathletes or it's going to be 3 mathletes. Everybody see that word at least in there? That's important. Now pay attention to it. What is the probability of a team with exactly 1 mathlete? So 1 mathlete would be 5C1 times 6C2. Because exactly 1 mathlete would be 1 mathlete and 2 football players, right? But this is a probability question. That means it must have a denominator. Does everybody see that? This one says, what is the probability? What would the denominator be? 11C3. Why is the denominator 11C3? Total. How many total kids do I have? 11. How many total am I picking? 3. Your denominator is always the total. 200 students. 70 love Mountain Dew, 60 love Pepsi, 12 love both. Pick 1 student. What's the probability he won't like either? All right, another probability question. Think about a strategy. 70 love Mountain Dew, 60 love Pepsi, 12 love both.
So add the 200.
What are you thinking of setting this thing up? It screams Venn diagram to me. Don't you think about a Venn diagram? You got this Pepsi ball, you got this Mountain Dew ball, and you got overlap in between them. So here are my 200 students. some of them like Mountain Dew, some of them like Pepsi. We know 12 of them like both. Mountain Dew ball had 70 people in it, but 12 of them are in the overlap, so this must be 58. Right? The Pepsi ball had 60 in it, so this must be 48. How many people are represented in those balls?
118.
Yeah, I think it's 118, isn't it? Isn't it 118?
Yeah.
You got 58 plus 12 plus 48. Oh, I don't want to put 118 there.
You want 200.
82 goes here, right? Because 118 is in the circles. There's 200 people altogether. What are these 82? They don't like either. So the question said, what's the probability I'll pick somebody and he won't like either? 82 over 200. Or 41 over 100. Number 15, I squeezed in some up there at the top. Number 15, expand, oh lordy, 2x plus y to the fourth. This is like a review sheet, so we need to be able to do this. You remember how to do that? Expand that. You could FOIL it out. Takes a while, but you could. What else could we do? It's a binomial expansion, so we'll use the triangle. And the first thing we do is write out the coefficients we're going to use. They're going to be the fourth row of the triangle. Now the fourth row isn't very many, so I'm going to go ahead and work it out. We've talked about that your other option is to use the combination numbers. So this is 4C4, 4C3, 4C2. But when you're only going to the fourth row, it's just as easy to write it out. So we've got 1, 4, 6, 4, 1. Next to each of those, do you remember what we write? The two things. So that will be 2x and y. And these are the separate terms. And I don't know how much room you've left, but make sure you are separating your terms with plus signs because you don't want to start combining those terms. Those are individual terms. What's the last thing I need to do?
You need to put the coefficients.
I need to put the coefficients, or not coefficients, the exponents. Need to put the exponents on. So right here, this exponent is 4. No, the exponent's just 4. 4. And then this one is 3, 2, 1, 0. And then same thing, other direction. Because remember the little hint I gave you within each term? They got to add up to 4. So make sure they do. And then we simplify. Anything to the 0 power is 1, so we can ignore it. So what do we got right here? Yeah. 16, x to the 4th. That's why I put that in parentheses. Those parentheses are important. Plus, now be careful, what do we got here? 32 x cubed y. What do we got here? 24 x squared y squared. 8 xy cubed, and on the end, anything to the 0 is gone, so it's just y to the 4th. Everybody good with that? Now we're going to find the 4th term. Okay, so we're going to do essentially the same thing, but we're only going to find the 4th term. So this time, oh Lord, it's to the 10th power. So if I were going to use the triangle, I'd have to build a lot. I'm not going to do that this time. Okay, too big. So I'm going to remember that the first term is 10C10 in the triangle if I wrote it out. the first term of the 10th row would be 10C10. The second term would be 10C9, 10C8, 10C7. There's your coefficient. So yes, Brenton, 10C7 is what I'm starting with. Now, just like up here, we're only looking at one term instead of the whole thing. But next to that would be an x and a negative 3y. Right? And if I put my powers on, if I were writing out the whole row, here, the power on x would be 10. And then I would count down to 9, 8, 7.
Oh, yeah.
So my power on x is 7, and my power on the other thing then has to be 3. So then I need my calculator to figure out what 10C7 is. So that's 120. X to the 7th times negative 27y cubed. What in the heck? So I got for my final answer negative 3240 x to the 7th y cubed. Does that look okay to everybody? You follow all that? All right, one more question. This means the probability of A is 0.62. The probability of B is 0.71. The probability of A and B is 0.54. And your job is to find the probability of not A and not B, and the probability of not A and B. Oh boy.
It's like a Venn diagram.
Ah, yes. See, you just feel it. You just feel it. It feels like a Venn diagram. And it feels like a Venn diagram because you have these two sets and they are overlapping. It isn't that one depends on the other. That would be a tree diagram. You have two different sets, two things going on, A and B, and they overlap each other. That just screams Venn diagram. So, here's my A ball, here's my B ball. As always, you start with the overlap, if you have it, which we do. So in the center here is 0.54. So there's a 54% probability that somebody owns a Chevy and a Ford, whatever the two categories are. Now the whole A ball was 0.62, which means that this part is just 0.08. And the whole B ball was 0.71, which means this is 0.17. Right? Now, what have I got here all added up? Add all this up, what have I got? $79. So there's a 79% chance you're in a ball, which means there is a 21% chance that you're not A or B. You don't drive a Ford or a Chevy. Right? Now, what's this question want to know? What's the probability that you're not in A and you're not in B? Wouldn't that be everybody outside the circles? So that's 0.21. You're not in A and you're not in B. So you must be outside of the circles. Now what does this say? You're not in A, but you are in B. So you can't be in A, but you have to be in B. What's your probability? 0.17. Those are the people that are in B and not in A. Remember, This means and. So you cannot be in A and you need to be in B. Well, the only people that satisfy both of those are the 0.17. Would you agree?
Does the one that faces left or?
Yes. And then you would include everything.
So if you ever think about what's the difference with J? What's the